Okay, all right. Now that I'm recording, I'm going to go ahead and repeat what I just said. I'm going to keep today relatively short because I'm going to go through and I'm going to cover the four next. Then I'm going to go back and look at the assignment that I gave you to do, and I'm going to do the first part of that. That there, and then the second two parts you have to do. And when I get into it, you'll see that you need to have the first part to do the second two right there. And keep in mind that this assignment that I'm giving you, I'm having you turn that in, but I'm going to actually have an in-class an assignment where I'm going to give you a small program, something you could do in an hour or so. I'm at there, if you've done the other two and understood them. So the warning is that if you work in a group, and do the homework, everybody in the class is going to be responsible for doing another program like that on their own without the group. So obviously the one that I will give you in class will be easier than the ones that they're, but if you didn't understand it when your group was doing it, I'll find out about it real quick when I start looking at and that's the one that's going to be entered in the grade book. So, and one of the problems that I ran into last time, and it's my fault in the way that I teach this class, the fact that I have only assignments turned in, I got everybody in the class ended up with the same grade that there, and everybody ended up with getting 100% on all the homework because everybody got the homework done and because they all worked in groups and turned in the homework. So now I have to have a way of differentiating those who do understand it versus those who don't. And the only way I can do that is with in-class assignments. The other way I could do it, and this one is much, much harder on me, and I'm way too lazy to do it, and that is to give each person in the room a different assignment. And you can see why that would be a very difficult task for me to do. I mean, that's kind of what FYP is that each person has a different assignment that they're, and you're forced to do it individually. You can get help, but no one's going to do your FYP for you because, that they're, but your FYP is different than his FYP, so he's not going to do his and yours that there. Unless you're engaged to get married, and then maybe you might talk him into it. That's there, or maybe it might be the other way around. He may talk her into doing his that there. But again, keep that there. So chapter 4 is our next chapter, and I don't know how far I'm going to get in this book. I want to get at least through 5 or 6, and then I need to switch over to MATLAB. So that there. Well, let me just kind of start again from chapter 4. Let me get the pen out, and I keep forgetting to bring my other pen. I've got two of these pens because I've got two. I got an older version of this computer that turns on some of the time, and some of the times it don't. That's why I retired it right there. But slideshow from the beginning. Let's just kind of that there, and it works today. Okay, so. Magic Pen works today. That there. I've yet to figure out why it doesn't work on certain days, but that there. Okay, that there. Well, I'm going to concentrate today is again we're doing iterations, which iterations is a fancy term for loops. We're going to do something over and over and over again, right there. So, an example of that is I've got a niece that lives in actually. I guess, I call her my niece because in the States we refer to our spouses' nieces as our nieces, that there. But I guess it's my wife's niece who lives in Seminary, and she bakes cupcakes. She's a baker. She actually used to teach English at one time, or not English, Islamic studies, I think, on Fridays or so. But that's my niece. She's now basically a full-time baker, and when she makes cupcakes, and she's going to make 40 cupcakes, she does 40 steps that are the same. She puts the cupcake holder in the pan, she fills with batter, and then she puts the next cupcake hold, cup in the hand, pours it full of batter, and she will repeat this 32 times. That's a loop. If you're an auto mechanic and you've got to change 8 spark plugs, although 8-cylinder engines aren't common in Malaysia, they used to be very common in the States. You would remove each spark plug at a time, and you would repeat all the steps in that loop 8 times to change 8 spark plugs. Right there. Most of my cars up till probably the mid-90s were all 8 cylinders. I mean, US used to use 8 cylinders. Now it's mostly 6 cylinders. And I think most cars, I had a 3-cylinder car here at one time. I can't tell I had a 3-cylinder engine, and I never seen that before out there. So, but again, those are loops. It repeats that there. So the next part of this, and we'll get to this next week, is using the switch statement. And the switch statement is like a fancy if-else statement right there. So we're looking at the do while is just like the while statement, only we put the condition at the end of the loop right there instead of the beginning of the loop. I personally don't use do whiles too much at there. I'll cover them because the book covers them, and you might run across them, but the do while is not really a necessary part of the language. The while is that there, and the for is definitely part of that there. All right, now I did this the other day, and I'm just going to kind of go through that, go through it relatively quickly. That there. All right, so whenever we're doing a counter, this is showing a while loop that's actually behaving more effectively if we were to do a for loop for this right here. We initialize our counter to 1. And while the counter is less than or equal to 10, we go through the loop one more time. And inside our loop, we increment our counter right there. Now, we can do for loops this way. We don't need to use for loops. We can use the while loop that there. But life would be simpler if I combined all 3 steps into one. The 3 steps are highlighted. One is we check, or we initialize our counter variable to 1 right there. So we do our initialization first. The second thing is we do our check to see whether or not the condition is still true. And then the third thing is we increment our counter. Those are the 3 steps in a while loop that does a certain number of iterations right there. So this kind of goes through the same thing. And again, right here. Now here, what he's doing is he's combining the iteration into the while statement by using the plus plus. And remember what I said yesterday, that whenever you use the plus plus in a more complex statement, you run into the risk of making your code more, and I'm going to use the word cryptic. I know that's not a common word in my English, but cryptic means hard to understand. In a prior lifetime, I was in the Air Force, and one of my jobs was, my only job full-time once I got out of school was code breaking. I worked in cryptology and Morse code there, so cryptology was a field that I'm quite familiar with at one time. So it meant something different to the code breakers out there, and without going into much detail, my job was sitting in England listening to Russian radio transmitters and seeing what the Russians were doing, because we were still, at that time, the Soviet Union was the big enemy of the Western world, and we had to spy on them, right? There, I mean, so that's what I did for 4 years, was I spied on the Russians. That there. So the only useful skill that I learned from that, by the way, was typing. That there. Nothing else I learned in code school is of any use to me in industry. But when we put this plus plus in there, we make this cryptic right there. So right there. Now, one of the things he does point out, and I didn't point out to it last time, I skipped through this, but if we use floating point variables are not necessarily 100% accurate. They're an approximation. So whenever we do any kind of for statement or a while statement where we're doing this there, we should almost always use integer values. That there. So this is too many levels of nesting makes the program difficult. Again, that goes back to if I have a while here, and then I have, at the end of the while, I have my break here, and then I have another while right here. There's my brace. I have another while right here. Here's my brace. And then I start putting my ending braces right here, another end brace, and then another end brace. See, what I'm showing here is that I've nested this loop I've got 3 loops together. Now, you'll have to do this for your lab, by the way. Your lab, you'll have to nest twice right there. So that's one of those issues that you have to do. So sometimes you do have to nest loops. But what he's saying as a rule, try to avoid more than 3 if you can. Out there. I've actually nested them 7, 8 deep, because I had no choice. Right there. And it talks about that there. Okay, the for statement is what we're looking at here. Here's the example of the for statement right here. And this is going through here for. Now, as I mentioned before, that's the initialization part of the for statement. You can use any integer variable in there, and I can say for I equals 1, for open bracket I equals 1, then semicolon I less than or equal to 10, and semicolon I plus plus or plus plus I. It doesn't matter whether the pluses are before or after, because this right here is a standalone statement right there, plus plus counter. So it's not part of an equation, so it doesn't matter when I increment the counter. So it can be counter plus plus or plus plus counter. It behaves exactly the same. It doesn't make it any difference where I put that plus plus. That there. This unsigned int right here, this part right here, that there, what that does is that assigns a place in memory. It's an integer, and it's called counter right there. So it's the same as initializing it at the beginning of the program, except for when I do it in the for statement, that becomes a local temporary variable. So in other words, int only exists until the loop is over with. Once the loop is over with, int is freed and it's no longer using space in memory. So that's an advantage if you want to save memory. Now, today's desktop computers, I think these are older. I think these only got 4 gig of RAM. 4 gig of RAM is 4 billion bytes. Int takes up 1 byte, maybe 2 depending on the compiler. So out of 4 billion bytes available to you of memory, saving 2 doesn't really mean much, right? That there. So it's completely up to you whether you want to follow this. Now, if you're working with a PIC microcontroller or a 8051 microcontroller or some of the smaller ARM microcontrollers, and some of these microcontrollers only have 256 bytes of available memory, then all of a sudden saving a byte or two means a lot. So a lot of us older people that, or those of us that have worked with microcontrollers instead of desktop microcomputer systems, tend to like to save memory. That's there. In this class, yeah, memory is free. I mean, you've got all the memory you want. So putting the unsigned int, but the other advantage is this counter right here, this variable counter, can be used elsewhere. Now, kind of an interesting thing, and this can make debugging programs a heartache and a major pain in the neck, is a counter can be used as a variable up here. In other words, I can define a counter variable here, and then I redefine it within this loop. So it means something inside the loop that's different than what's outside the loop. And that creates all kind of heartache. So if you're going to do it, make sure that you don't reuse that other than maybe other loops or elsewhere. But don't make it a global variable or a function-wide variable, or in this case, the only function we have is main up there. So the for loop right there, and I'm just going to skip to this right here. This is the components that we use typically for our loop statement right there. For is the keyword right there. The first part of our very first statement, there's 3 statements within the parentheses. So you got a pair of parentheses right here and here. And we got 3 statements here. 1, 2, and 3. The first one is the initial value of the controller. That's how we set up what the starting point is. The second one is our condition. The loop will continue until this condition becomes false. In this particular case, our condition is counter is less than or equal to 10. And these are the same conditions I talked about with the if statement. Right there, same conditions. We cover the if statements and all the various. This here has to evaluate as true or false. Right there. So our condition has to be either true or false. As long as it's true, it continues to work in the loop. Now, where things get sometimes confusing, that some programmers will leave the condition blank, which means that it's always true, and what they've essentially done is create an infinite loop right there. So if you leave that blank, it's always true. Or they'll put a 1 in there. If they put a 1 in there, it's always true. That's it. So, and then the last one here is what is done after each iteration of the loop. Now this is doing plus counter. I can do whatever I want in that. I can do a for, and I'm going to use float right there. X is equal to 0. I'm going to say x less than or equal to 2 times, and I'm going to put the word pi right there. We'll assume that pi is declared someplace right there, and semicolon x plus equals 0.1 right there. And this is going to go through, and it's going to go from 0 to 2 pi at increments of 0.1. And 2 pi, of course, is 6.28, right? So it's going to run about 62 times, 63 times. And then we can calculate y is equal to the cosine of x or whatever we want there. And print out a table the cosine of x for a number of values right there. So, but notice here that this last statement is not a plus plus, it's a plus equal, and I'm adding 0.1. And I just violated that one rule he talked about, and that is that I'm using a float value. Now, it's okay to use a float value in this case, and the reason I say it's okay in this case right here is that I'm using a less than or equal to. Less than and equal to, you can use floats. That they're equal, you cannot use floats right there. So that's one of those really cases that you just simply have to look at it, because eventually x is going to be greater than 2 times pi. So it's going to drop out of the loop. But if I said until it's equal to 2 pi, it may never drop out of the loop because it may never be equal to 2 pi. Right there. It may come close to 2 pi, but it's not going to become equal to it. So I just want to kind of point out here is that I use this less than or equal to, I'm allowed to use floating point right there. And my increment is not just plus right there. Now, I'm tired of red. I want to find a different color. Let's go with purple right there. I like purple, as you can see with the coffee cup in that there. So, right there. Okay, right there. For the control variable, this is a problem here. I didn't talk about this last time. Remember what I said is that when I define the variable here, this is where I define counter right there. Counter is defined only within the loop right there. And what it says, for a control variable defined in the statement header, which is what I've done, or that there, the for is the statement header is what he's talking about there. If I try to access the control variable after the closing break, so what he's saying here is for I int, and I can't write. I shouldn't say that. For about 3 months, I couldn't use this right hand, so I couldn't write for a while. So for int I equals 0, I less than or equal to 10, I plus plus, right there. I have a brace, I have some brace, I have some code in here, we don't know what the code is. And I do a print F percent D. I don't want that little, he just likes to do that once in a while. Percent D, comma I, right here. What this is saying right here is that I is defined here. This is where I define I. Here, everywhere in here, I can be used. I is okay inside these braces. So between here and here, I is fine. Once I enter that closing brace, right there, this I right here is undefined. In other words, it means nothing right there. It's completely, the value is lost when I hit that closing brace. So, yeah, you got to make up your mind. Do you need the value of the counter after the loop is over with? Right there. Yeah, that's just one of those errors that you can come up with. I hate to say it, I normally just define my counter I, J, and K as my temporary counter variables at the beginning of my code. But remember, I grew up with Fortran. In Fortran, we only were allowed 2 letters for a variable name, And if we didn't define integers and floats, anything that started with I, J, K, L, M, and N, and O, I think O might have been, O may have been a floating point. But I, J, and K, L, and M, and N were all considered integer variables right there. If it started with A, B, C, D, E, F, G, it was considered a floating point. So I tend to use a lot of those habits from my old Fortran days. You're starting off with your first language is C. You're not restricted by Fortran rules that died in 1985 or so, right there. I mean, BASIC tended to get rid of a lot of those rules, but a lot of us who took our first programming class in Fortran tend to follow these rules right there. You also notice that there is that if you use less than or equal to, it's going to do it 10 up till 10. If you forget the equal, then it's only going to do it 9 times right there. So that's just a common error that a lot of you will run into right there. So the general format right there. Comma, separate list of expressions. I have never used a comma there. Does he even show an example of it? No. Not there. He goes through this whole discussion on comma, separate list of expressions, initializations, or comma. What he's saying is that there, I know what he's talking about, and don't do it. Just don't do it. Right there. What he's talking about, right here, I'm going to erase all this so I can reuse this slide, is that I could put a comma here and a second expression here. So I could do 2 things in that last one. I could do 2 things here. There, I can initialize 2 different variables at the top. There. So, and I put a comma in between each of the expressions, because this can be any, right here, this can be any valid executable statement. This can be any valid executable statement. It doesn't have to initialize a counter. The syntax allows us to do whatever we want. Remember one of the problems I said with C? It lets you do whatever you want. Even if what you want to do is stupid and cryptic and cause you heartache, there, I can put anything I want in that initialization block, anything. So, I can put another for statement in there if I wanted to. Why I would, I don't know, but I can put, any kind of expression. I could put a formula in here. And I think he showed an example of that in one of the later slides where you can put a formula there. It can be any executable statement you want it to be. And not only can it be one executable statement, I can have 2 or 3 executable statements in there. Now, what did I say about keeping your code simple and readable and easy? There's a saying in English, I don't know if it translates into Malay, but we call it KISS. And KISS is one of those rules of programming. And KISS simply translates to keep it simple, stupid. There. You follow the KISS principle. You keep it as simple as you can in order not to get lost in the code. And as soon as you start doing this often initialization or comma lists, there, as soon as you start doing this, you're no longer simple right there. So the commas used are actually comma operators, I guarantee that there. Notice he doesn't give an example. I was looking for an example of it because it didn't dawn on me what he was talking about, because I never do it. Out there, I tend to follow that KISS simple philosophy as much as I can. So it's often used. The comment is most often used that their primary is to enable multiple initialization or multiple increment expressions. Right there. So, right there. Software only place expressions. That there. And here he mentioned, and I talked about this again. I'm repeating the slides I know I talked about yesterday, but some slides are worth repeating. That there. He's saying that I don't have to have any of those statements in there. I can have four semicolon, semicolon like that in my body of the loop. Now, notice if I do that, there's no initialization. There's no increment or decrement operator. Most importantly, there's no condition. So if there's no condition, the condition is true, right? So what I've created here is a infinite loop. It will keep going forever and ever and ever and ever. And I don't know if I told this class about one of my first jobs on an assembly line. It's the only job I ever did on an assembly line. That there was that I sat on a bar stool, one of those little lab bench stools. We call them bar stools because you see them in bars more than you see them in labs in the U.S. But you know what I'm talking about, the little stools that there. And there was a conveyor belt that speaker cones went by, for loudspeakers like you would put in, a stereo system or your car or whatever. And there was a tray full of the little magnetic cores, only they weren't magnetized yet. And my job was to reach over, pick up one of those cores and put it on the speaker as they went by, over and over and over and over and over. That seemed like an infinite loop to me. That's there. You kept doing the same thing. But there are some programs that you want to be infinite loops. That there. You don't want a petrol pump to process one customer and then stop. Right there. You want it to keep processing customers. That there. Because your petrol station is open 24 hours a day, 7 days a week. So you never want the program to end. So that would be in an infinite loop. Now there may be some inner loops in there that would do things like print out daily totals and check, how much petrol's in the tank and things like that. But the overall program runs 24 hours a day, 7 days a week. There's lots of those kinds of programs out there in embedded systems, right there. So I have used this for that there. I tend for embedded loops, I actually tend to use the while more. And usually I declare a variable, hell freezes over and set it equal to false. And then I say while not hell frozen over. That there, in other words, this program keeps going until that there. I'll probably change that if I ever do any embedded things there till it snows in Kuala Lumpur. That there. Do until snow falls in Kuala Lumpur. That there. And of course, snow doesn't fall in Kuala Lumpur, right? And if it does, then I don't care if my program is working or not because things have changed right there. So, but again, we can here he talks about the fact that all four of those are same. We covered that yesterday. Using commas instead of semicolons, that there is an error. They have to be semicolons between the statements. That's there. And I think this is kind of where I ended yesterday, but I spent most of my hour just redoing yesterday's slides. But I want to make sure that they're clear. Right there. Here, notice my condition is fairly complex right there. J is less than or equal to 4 times x times y. Here, I'm not doing an add or subtract, I'm dividing J is equal to Y divided by X right there. And then I started off with J is equal to X right there. So these are not necessarily, simple. That there. So the increment can be negative, so in which case it counts down right there. So now notice that the last one is an important one. If the statement, the first time we go through the loop is already false, the loop is skipped altogether right there. So, and here the control variable is frequently put there, but it need not be. Notice here that he doesn't declare counter there. Counter has to be declared elsewhere. So this is where, again, C gets a little bit complicated. You have two different syntaxes. Earlier, we put int in front of counter, in which case we're declaring counter in the for statement. Now, we're not putting the int in front of it, so counter has to be defined somewhere else in the program. Right there. And and anyone who says that C is an easy language has actually been spending too much time in the what they call that stuff that people drink from the palm trees. I can't remember what it is, but it's an intoxicating beverage right there. So, oh man, I just drew a blank. But that they're, or they've been doing something that alters their mind thinking. If the first time you look at C and you think it's an easy language, there's definitely something wrong with you. You're back in that mentally ill category, not brain damage category. There are easier languages to learn than C first time, right there. So right there. Okay, this is just kind of going through examples using the for. Right here. The one that's kind of interesting is this last one. This last one does a decrement instead of a add. It says J is equal to J minus 11 right there. So it's taking 11 away from J each time. Here we're doing a minus 1 right there. So we're setting I is equal to 100 and we're counting down to 1 right there. So some of these others here, this is the more common, the plus 1. Here we're adding 7 to it. Here we're subtracting 2. Here we're adding 3. We have all kinds of options here. And also notice that none of these are declaring I in that there. And remember what I said where this I comes from. You can tell that the original author of the book, Paul Decto, is the original name, and not his son wrote these parts, because obviously Paul, the original author, he's an old man. He's even older than I am. Imagine that he's up in his 70s by now. He definitely learned with Fortran as his first language, so you'll see this I used a lot right there. Okay, all right. What I'm going to do right here. Oh, I love this problem here. Actually, that may actually become an assignment. That may be your classroom assignment. Oh, no, I just told you one to look at that there. One of the things I like to do is to show what happens if you put money in a bank and you let it draw interest for so long. And I'll probably give you the other formula, and the formula is if I took the way that I would word the problem. So I'm going to throw this out as a huge hint for the classroom, is that there's a formula that says that if I take 100 ringgits out of my check every month and put it in a growth mutual fund or a trust fund that grows at 8% interest a year, how much money does that 100 ringgits per month come out to be when I turn 55? And the answer will actually scare you, because it'll be into the millions of reigns right there. So it's one of those cases that if you start young, I started at 27 putting money into my retirement account in the U.S., which is in mutual funds. And I'm not going to say how much is in there, but it's, you know, I'm working because I enjoy working. I don't, there's enough money there that I don't need to worry about it. And that's why, one of those things I try to stress on young people is if you start in your 20s saving money and you never touch it until you're ready to retire, forget the EPF. I'm not saying the EPF's bad. The EPF kind of emulates the same thing, but EPF pays about 5-6%, normally about 5% interest, and it's only paid once a year. So if you look for better investments, you can do that there. But the key thing is you put money someplace. But I like this example. Okay, let me bail out here. And actually, if I go to desktop, capture. All right, this is the assignment I gave you. You should have seen it. I put it on Facebook. I think I put it on Facebook twice by accident there. There's 4 parts of this. There are 3 parts of this. The first part is write a program that reads a non-negative integer and computes its factorial. The second 2 parts is that I have to use the factorial within calculating the answer right there. The factorial is part of that there. So that has to be a loop within that there. Now, these are infinite series, so and it doesn't necessarily tell you write a program that estimates using the formula. You can only go you don't go forever. Just do like the first 10 or 15 terms right there. But E is equal to 1 plus 1 over 1 factorial plus 1 over 2 factorial plus 1 over 6 or 1 over 3 factorial. So you need to be able to do the factorial. Now, later on, we'll write factorial as a function, and we'll call factorial. But now we're going to do it within the loop right there. So what I want to do is just spend the next, and actually I don't know what I've got on time. I don't care because I'm going to finish. Oh, I got 15 minutes. Still be within my normal hour right there. So that there, and if I go over, I'm allowed an hour and 45 minutes, right, or an hour and a half. So that there, but I'm just going to write a short little program that does the factorial. And I didn't write this ahead of time. So if I make stupid mistakes as I'm doing it and I come up with the wrong answer, well, that's part of what you'll do, right? That there. So, and it doesn't necessarily hurt. So I went ahead and brought up DevC. Now I think these 2 computers had trouble with DevC, didn't they? So you may have to go and use the 2 computers in the back of the room or something. But some of these computers had trouble with DevC not crashing. But I'm going to go ahead and I'm going to create a new project right there. And this is a console project. And I'm going to just call it factorial right there. It's a C project right there. And I click make that the default language. It doesn't really matter whether you check that or not. Don't check C++. Because C++ is a good language, nothing wrong. I actually taught this class with C++ once, and the problem I ran into is I said that C was a bad first language, C++ was even a worse first language. That there, the syntax is different. At the factorial. All right, and I'm just going to create a new this, I don't want this PC, I want documents. And I'm going to call it factorial. Now, it's a good idea to create a new directory for every new project you create. Otherwise, you end up with all kinds of files getting intertwined. So anytime I create a new project, I create a new directory for it. And I'm kind of repeating some of the things I did earlier in the semester. Right there. So, save. All right, this brings it up here, and this is the code that it gives me for our main.c. I'm going to call this. Now notice that it's already got the two include lines there. So it's already including standard IO and standard library right there. And we're not using standard libraries at all, but at this point here. And it's got a argument list after main. We're not going to pass anything to main, so I'm going to actually delete this. And put the word void right there. So basically we're not passing anything to our program, so let's just go ahead and put void in there. So right there. And I'm going to go int counter right there because I'm used to doing this that way there. I'm also going to do int n, and int, that is our number. We're going to count the factorial in there. So the first thing we're going to do is we're going to ask the user for what number we're going to put there. So let's just do a printf. And I can do it either way. I'm going to do the %s there. And enter the number you want to use for this program, colon. And I'm going to put a space there. And we're going to scanf. And it's going to be a decimal. And we're going to pass it the address of n right there. So all we've done here, and notice that I'm typing this off the top of my head. I'm not doing any flow charting or pseudocode. You might want to do pseudocode before you do this. I'm an old guy who's wrote a lot of C programs, so I can think in terms of C versus pseudocode out there. So now what we're going to do is we're going to also add another variable here. And I'm going to go up and I can do it right here. Int fact equals 1 right there. And what I've done there is violated my own rule, but I just showed that I can declare a new variable in the middle of the program and I initialize it as 1 right there. So what we can do then is we can then write our for loop. For counter equals 1, counter less than or equal to n right there, and counter plus plus right there. We put our brace there. So what we're going to do is we're going to go from 1 to n. So if we put in 5, we'll go from 1 to 5 right there. And then we can just simply say is that fact is, and I just broke this thing. I deleted the closing brace here. Fact multiply equal counter right there. So we're going to say fact is equal to fact times the counter. So the first time through, it's going to be, fact is already 1. The first time through, it's going to be 1 times 1, which is 1. Next time through, it's going to be 1 times 2, then 1, then whatever that answer is, times 3, right there. And I'm going to print, the percent I value of percent I fact is percent I slash n, and I'm going to say counter and fact, just to show the individual steps right there. And then after the loop is over with, print f the factorial of percent I up. One of the reasons I don't like touchpads, I thought I'd turn that off. That there. Normally when I have a mouse operating, I turn the touchpad off because my thumb accidentally hits it. Right there. Factorial percent I is percent I. And n and fact, right. Now, if we're lucky, this will work right the first time. Now, again, I am totally capable of making mistakes, so we'll see if this works right the first time. But logically, this should work, because what I'm trying to do is that fact is 1 and counter is 1, right? So this is, we start off with 1. So I'm going to put over here counter right there. That's a 1. So 1 times 1 is 1, right? Second time, this is 2. 2 times 1 is 2. Now this is now going to be a 3. So 3 times 2 is going to be 6. Right there. This is a 4. So 4 times 6 is 24, right? If I'm doing the math. This is 5. And so this is like 120. If this is 6, it goes to 7. That there. And on and on and on. That there. So that's the logic that I'm using right there. So if we take this and file, save as, and I'm just going to call it fact, tutorial, right there, and right there, I don't like it, for whatever reason, it defaults to the name of the function, right there. So let's execute. First thing is I compile it, and all right, 0 warnings, 0 errors. So evidently I got my syntax straight. I'm doing pretty good for today, right there. So now we turn right around and we're just going to execute this. We're just going to execute it, and we're just going to hit run. And let's just do 5, and lo and behold, it gives me the right answer. So, if I run this again, execute, run, and we say 100, and it doesn't work. And the reason it doesn't work is because I've overflowed the integer right there. So it looks like it worked up to about 15 or about 13, and then it crashed. So in this particular case, because of our numbers we've gone over the maximum integer right there. That's why I can't go for like a 100 there. That's, and I expected that, by the way. I knew as soon as I put in 100 there, that's going to just simply crash right there. But I can run this again. No. Oh, run is F10 right there. But I can put in 20 right there. And as you can see, actually 20 it crashes. Actually it crashes, it looks like at about 9 right there. Now I can make it go farther, but I can, so declaring things as int, I declare them as longs right there. We haven't talked about this, but counter, if I make fact a long right there, and I think that'll work. Oh, but it doesn't like long right there. Oh, long. I had an F in there, which is yeah, it still is crashing about 9. So evidently, actually the problem is that I need to tell that to do long arithmetic there, and it probably will still not work too long right there. Oh, I did that in the wrong place. Yeah, it's still crashing about 9. Even the long is not letting me. I'd have to set it up as a floating point in order to get it to work, in order to handle the larger numbers. So, but keep in mind though that this part here is what you need to use for within your program. You have to calculate the factorial right there. So, and you would start this right here, and n is the number you're going to do this at there. So if I wanted to do the factorial of say 1 up to, and I said for your problem to go up to like 10, take that to 5, because we know that 9 crashes the factorial right there. But let me comment this out right here, and I'm going to put this in another loop right here. I'm going to delete. I'm going to leave this here because you'll need that for your, actually you don't. Let me look at the assignment again. E to the x. Well, for the second one, you'll have to use the, you'll have to put in enter the value for x right there. So right there. But let me go back to this right here. And let me look at the first one here. And I'm not going to finish it for you, but I'm going to kind of, well, I mean, I'm finishing it. Let me just kind of go through and do that there. So we're going to look at, I'm going to declare another variable right here. And I'm going to call it float. And I'm going to call it calc E right there. So that's the variable that I'm going to calculate to. I'm not going to worry about the numbers, any number that I put in for right now, because we're just calculating E for right now. Right there. So again, what we're going to do here is that we're going to, at this point, we're going to put another loop in. Right there. So what I want to do here is I want to take this right here. I've deleted that. Let's just go ahead and at there. And I'm just going to put another loop in right here. And I'm going to just say, I'm just going to use I equals 1 I less than, we'll say 5 I plus plus. Now what I'm going to do here is I'm going to take this, cut this, and put it inside that loop right there. So what we're going to do that there, and here I'm going to use I here, right there, because we're going to calculate that there. And then at the end of this right here, calculate factorial, okay, long I right there. And what we're going to do is we're going to say calc E is equal to calc E plus 1 divided by fact right there. Because what we're trying to calculate is, remember, E is equal to 1 plus 1 over 2 factorial, right? Plus 1 over 3 factorial plus 1 over 4 factorial plus 1 over 5 factorial. Now, I stopped it at 5. It goes on forever. But obviously, we found that the factorial function blows up on us right there, you know, as we go through and do our calculations right there. So what I'm doing here is that I'm calculating the factorial of 1 first, and I'm saying that fact is equal to fact, you know, right here. And now I'm doing this 1 to 5. The first time through the factorial, it's going to be equal to a 1 right there. The second time, it's going to be equal to 2, so this will take me up to 5. And I'm going to say less than or equal to 5 so that we include right there, less than or equal to 5 right there. So, and we go through and we calculate it. And we'll see how this works out. I'm going to go ahead and put this printf in there so that we can see that it's calculating the factorial right for each one right there. And then I'm going to down here, the value of E is and this is a floating point. Calc E. All right. I don't need that. I don't know if this is going to work. you know, I'm just doing this off the top of my head. This is intended for you to spend a couple hours sitting there fighting with, but that's there. But we'll see. For loop calculations, declarations are only allowed in it doesn't like the fact that I declared I here. Why doesn't it like that? It worked a minute ago, but oh, that's all right. Well, we will clear I up here. I don't know why it didn't like that, but and calc E, that looks like a true misspelling right there. All right, I compiled right. Now, whether or not it worked right or not, I don't know, but we'll just see here. So I just run it. There's no input, so it'll just, and it says the value of E is 5, which is a long ways away from the value of E, which is right there. The fact value of, it looks like it's got some errors in. All right, where's my, it looks like there's an error in the calculations right there. Fact is equal to, oh, you know what? We need to do our loop counting that there. Let's try this again. Execute. 1, the value of E is 1. So it tells that the value of E is 1 equals it may require that there. Still gives me the value of E is 1. Something is not right. It's doing the calculation right there, and actually that should be less than that there. Or counter is equal to float plus 1 over fact right there. I'm going to put another one here, right here, in calc E and as you can see, I can see what Calc E is doing in between that there. Calc E is equal to, this should work, but I am drawing a blank on why it's not. And always says Calc E is equal to 1. Right there. And one over factor, something. Let's take this long out. We don't need the long. Make the int again. We're only going to 5. As I look at this and I go, why is this not working here? Because that Calc E plus 1. You know, I'm seeing float right there. You know what? Let's make this a float too. Let's make everything float. Right there. Float. Now we're getting closer right there. Right there. Let's take it on up to about 9 and see what happens. You know, I made factorial floats, so we can go. It's still, it's getting higher though. I mean, but remember this is an infinite series. It looks like it's off by a factor of 1, to be honest with you. Right there. We may have to initialize this to 1. Right there. See, now we're getting pretty close. Right there. So, because if I run this again, if this is a floating point, I could probably make this up. It blows up on us. No, it doesn't. It doesn't. It gives us the right value. So, okay. So we have to start off with Calc E is equal to 1, because as we look at the formula again, let me look at the formula again. Well, yeah, the formula has 1 plus 1 over 1. So I need to initialize it to 1. So that's correct, that there. But obviously what we've discovered with this right here is that we need to use floating points in order for this to work. I'm going to go ahead and put this up there. It shouldn't be that hard to modify this for the last part. Because the last part, you would put the value, because if you look at the last part, the only thing that changes is this little line right here. Because the last part of this simply and why is it all I want to do is just, it's in this weird mode that I can't, I don't use this particular program much. Let's just reopen it. Is that it's 1 plus x over, and then you got to replace that with x squared, x cubed, x right there. So I've done this one for you right there. Let me save it. Factorial C. And I will be a nice person. Not, you know, my wife says I'm not a nice person once in a while, but that's all right. And I'm going to go to Facebook. And I will go ahead and put that file up there on Facebook. Right there. What is that? We don't care. And I'm going to call this, what is it? E-program. Right there. And oh, excuse me here. I need to go into the computer programming. I have to put it here. Somebody wants to join. Who wants to join this group? Right here? Somebody wants to join the group. All right. I never check, so. Sometimes I check the people that are in the group, and I find people from all around the world. So some people outside this class find this group. But program from today's date is 7th, right? Right there, and more. Add file. If I don't do this, then I'll forget it. Documents, factorial. Okay, so at least you've got the starting point for the assignment there. So, all right. With that said, this is one of